So number 4 then from paper 1 of the 2023 Higher Maths, 5-mark question for those compound angle formulae. There's the standard one. You've got these two right angled triangles, and from that you have to find presumably p plus q, sine or cos of it. It says, determine the value of cos p and cos q, and hence cos p plus q. I don't know if that's just in there to try and trick you. So cos p first of all. Well, the cosine of p is the adjacent over the hypotenuse. You don't know the adjacent, so you're going to have to use Pythagoras, but you do know it straight away because you've got a 3, 4, 5 triangle. So that was quite handy. I might as well do this one while I'm at it. So 3 and 6, what would that give for the hypotenuse? Well, that would be 9 and 36. So that's the square root of 45, but there's 9 in both. Well, it was 3 in both of them. That was really 3 times a 1, 2, so it's 3 root 5. But anyway, I've done it now. So 9 comes out as 3, so it's 3 root 5. It's presumably, well, there might not be a mark for that. But anyway, cos p. Adjacent over the hypotenuse, 3/5. 2. Cos q. Similarly, adjacent over hypotenuse. Still 3, but over 3 root 5. I think if you left it as root 45, it would have to be simplified here, which means that actually becomes 1 upon root 5. So those are the two results for part A. B, cos p plus q. Now, presumably, that's maybe there to trick the unwary into think you just add the two of those together. No, double check by looking at the front. And that's the one that goes cos, cos, sine, sine, but with the reversal. When it's a plus, it's a minus. So that's going to go to, I think I'll put it down here, cos p cos q minus sine p sine q. So just put them in. Well, I've got those already. 3/5 times, and the other one was 3 over, but then 1 over root 5, it cancels too. Minus, now the sign is the opposite, so that's 4/5 times, and the sign is opposite is 6, but if it's 6 over the 3, that'll be a 2 on top, so that's actually 2 over root 5, so that matched quite well. Well, now you've got this common denominator of 5 root 5, and the numerators will be 3 1s are 3, 4 2s are 8, so that's a negative 5. It gets better. So you've got negative 5 over 5 root 5. So this actually simplifies all the way down to 1 upon root 5. That was quite a neat one. Number 5 for 3 marks. You've got this equation here, 2x squared plus, and for the coefficient of x, so you've got this expression, 3p minus 2, and then plus p as a constant on its own. Determine the values of p so that this has got equal roots. Well, that'll be the discriminant then. Equal roots. Equal roots means that the content of the square root in the quadratic formula is 0, so you've got plus or minus 0. It means that the b squared minus 4ac part must come to 0. You just feed them in. So b, the middle one, the coefficient of x, that's 3p minus 2, and you have to square that, minus 4 times the a times the p. I'll just put it in there. That should come to 0. Right, we'll just have to solve this then. So multiplying that out, square the bracket. Square the first, 9p squared. Twice the product, minus 6 doubled, minus 12p. Square the last, plus 4, minus 8p. Almost there. 9p squared minus 20p plus 4 equals 0. Now, just have to factorise that then. But there's possibilities for both ends. So for 9, it could be 9 1, or it could be 3 3, and it could be 1 4 or 2 2. So if it was 1 4, could you multiply one of them by 4 and get them to add up to 20. No, so it must be 2, 2. So it must be 9p, p, 2 and 2, and they're both the same. So there you've got a minus 18 and a minus 2, so that's it. So either p is equal to 2 divided by the 9, or p is equal to 2. There's the two values.